Imagine this. You're watching this video right now, sitting still, relaxed, but you're not actually still at all. Right now, you're hurtling through space at over 1,000 miles per hour. That's the speed of Earth's rotation at the equator, faster than the speed of sound. Before we get started, check out the link in the description to download our ebook. Now, what if it just stopped? Not gradually, not slowly, but instantly, right now. What would happen to you? What would happen to the oceans, the atmosphere, everything? The answer is more terrifying than you think. And no, you wouldn't survive the first minute. Let me explain why. Earth's rotation is something we never think about. We can't feel it, we can't see it, but it's one of the most important forces keeping us alive. It controls our days and nights, our weather, our ocean currents, and even the shape of our planet. Today, we're diving into real science to answer one question. What would really happen if Earth stopped spinning? This isn't science fiction. This is physics, and it gets wild. Let's break it down, second by second. The first second, the catastrophe begins. Okay, so Earth stops rotating, completely, instantly. Here's the problem. You don't. Remember, you're moving at over 1,000 miles per hour. When Earth stops, you keep going. It's like slamming the brakes in a car, traveling at supersonic speed, except you're not wearing a seatbelt, and there are no brakes. Everything not anchored to the ground, everything on the surface, gets launched eastward at incredible speed. People, cars, buildings, trees. Anything loose becomes a projectile. You'd be thrown forward so violently that survival would be impossible for anyone near the equator. Even if you're farther north or south, where rotational speed is slower, the force would still be catastrophic. But that's just the beginning. The first minute. Winds like you've never seen. Now let's talk about the atmosphere. The air around you is also rotating with Earth at 1,000 miles per hour. When the ground stops, the atmosphere doesn't. What you'd get are winds moving at supersonic speeds. We're talking winds faster than any hurricane, any tornado, anything ever recorded. These winds would scour the surface of the planet, obliterating anything still standing. Forests would be ripped from the ground, mountains would be eroded in minutes, and it gets worse. The friction from these winds would generate immense heat. The atmosphere would ignite. Firestorms would erupt across the entire planet. The world would literally burn. Could we even survive the first minute? Not a chance. The first hour, the oceans attack. Let's say, hypothetically, you survived the initial chaos. Maybe you were deep underground. Maybe you were in a bunker. You're still not safe, because now the oceans move. Earth's oceans are also spinning at hundreds of miles per hour. When Earth stops, the water doesn't. It keeps moving east. Massive tsunamis, miles high, would surge across every continent. These aren't normal waves. These are walls of water traveling at the speed of a jet plane. Coastal cities? Gone in seconds. Inland areas? Submerged. The amount of water displaced would be incomprehensible. It would take hours for the oceans to settle, and by then, the geography of Earth would be unrecognizable. The first day, a world split in two. Okay, let's imagine the chaos settles. The fires die down, the oceans stop moving. What's left? Well, now you have a new problem. Earth is no longer rotating, which means no more day and night cycle. One side of Earth would face the sun. Constantly, the other side would face away. Forever, the side facing the sun would start heating up. Fast, temperatures would soar past 100 degrees Fahrenheit, then 150 degrees Fahrenheit, eventually reaching over 200 degrees Fahrenheit. The ground would crack, water would evaporate. It would become a scorched, uninhabitable desert. The dark side, it would freeze. Without sunlight, temperatures would plummet to hundreds of degrees below zero. The atmosphere would start to freeze and fall as snow. It would become a frozen wasteland. There would be a narrow band between the two sides, a twilight zone where temperatures might be survivable. But even there, the conditions would be extreme and constantly shifting. The first week, atmospheric collapse. Here's something you might not expect. Earth's rotation affects more than just the day-night cycle. It affects the entire atmosphere. Right now, Earth's rotation creates something called the Coriolis effect. This is what drives wind patterns, ocean currents, and weather systems. It's why hurricanes spin. It's why we have trade winds and jet streams. Without rotation, the Coriolis effect vanishes. Weather, as we know it, would stop. Instead, you'd get a single massive convection current. Hot air from the sunlit side would rise and flow toward the dark side. Cold air from the dark side would sink and flow back. This would create permanent, extreme winds blowing from the cold side to the hot side. Not as fast as the initial winds, but still powerful and relentless. These winds would carry what's left of the atmosphere, slowly moving it from one side of the planet to the other. Over time, the dark side would lose its atmosphere entirely. It would become airless, like the moon. The first month, the ocean migration. Remember those massive tsunamis? Well, over the following weeks, something even stranger happens. Earth isn't a perfect sphere. It's actually an oblate spheroid, slightly bulged at the equator because of centrifugal force from rotation. That bulge exists because Earth is spinning. Without rotation, gravity would start pulling the oceans toward the poles. The water would slowly migrate north and south, away from the equator. Eventually, you'd have two massive oceans at the north and south poles, and the equator would become dry land. A giant ring-shaped continent would emerge around the middle of the planet, but this new land wouldn't be habitable. It would be baked by the sun on one side and frozen solid on the other. The first year, magnetic field collapse. Now, let's talk about something invisible but critical: Earth's magnetic field. Earth's magnetic field is generated by the rotation of molten iron in the planet's core. This field protects us from solar radiation and cosmic rays. It's the reason we have an atmosphere at all. If Earth stopped rotating, the magnetic field would weaken and eventually collapse. Without it, solar wind would strip away what's left of the atmosphere, just like it did to Mars billions of years ago. Radiation levels would skyrocket. Any remaining life on the surface would be exposed to lethal doses. Even if you survived everything else, the radiation would finish the job. The long-term, a dead planet, fast forward a few decades. What does Earth look like now? It's unrecognizable. One side is a scorched, airless desert. The other is a frozen, dark wasteland. The oceans have pooled at the poles. The atmosphere is mostly gone. The magnetic field is dead. Life, if it exists at all, is deep underground or in isolated pockets near the twilight zone. Earth would resemble a lifeless rock, more like Mercury or Mars than the vibrant blue planet we know. And here's the thing, this would be permanent. Earth wouldn't just start spinning again. Without rotation, there's no recovery. The planet would remain locked in this state for billions of years. So, what have we learned? If Earth stopped rotating, it wouldn't just be inconvenient, it would be instantly catastrophic. We're talking total annihilation in the first few seconds. Global firestorms, continent drowning, tsunamis, atmospheric collapse, and eventually, the death of the planet itself. But here's the good news. Earth isn't going to stop spinning. The laws of physics won't allow it. The energy required to stop a spinning planet is incomprehensible. Short of a collision with another planet, Earth will keep rotating for billions of years. But this thought experiment shows us something important. Earth's rotation isn't just a random fact, it's the foundation of everything. Our 24-hour day, our weather, our oceans, our magnetic field, life itself. It all depends on the fact that we're spinning through space at 1,000 miles per hour. And honestly, that's pretty amazing. So the next time you're sitting still, remember, you're not still at all. You're on a spinning rock hurtling through the cosmos. And that spin is what makes everything possible. If you found this as mind-blowing as I did, hit that like button and subscribe for more wild science scenarios. And drop a comment. What other what-if questions should we tackle next? What if the moon disappeared? What if gravity doubled? Let me know. I'll see you in the next one.